studies section 9. Symbolizing statement and argument in propositional logic. Introduction. In this studies section, we will be discussing how to symbolize statement and argument in propositional logic. Our main focus here is to explore how to symbolize statements, determine truth value of propositions, and symbolize arguments. Learning outcomes. When you have studied this section, you should be able to symbolize statements, determine the truth value of propositions, symbolize argument. Symbolizing statements. In propositional logic, we make use of special symbols and alphabetical letters when symbolizing statements. Among the alphabetical letters, we have capital letters A to Z, also known as propositional constants, which are used to represent actual propositions. We also have small letters P to W, also known as propositional variables. Variables do not stand for actual proposition, but may be used to represent any proposition whatsoever. Among the symbols are those representing logical connectives as well as the various punctuation marks. In English language, punctuation is absolutely required if complicated statements are to be made clear. In writing a letter to our loved ones, for instance, we have to make use of different punctuation marks, otherwise our sentences will remain highly ambiguous. Punctuation is equally necessary in mathematics. For instance, the question 2 times 3 plus 5 can be interpreted as either 11 or 16. The first answer when the question is punctuated as bracket open 2 times 3 bracket closed plus 5, and the second when it is punctuated as 2 times bracket open 3 plus 5 bracket closed. Punctuation is also required in the language of symbolic logic for many reasons. First, where many simple statements are compounded into more complicated ones by various connectives, the use of punctuation marks enables us to know the dominant connective in the expression. Again, punctuations help to remove ambiguity from expressions. For instance, the expression P dot Q or R will remain ambiguous and can be interpreted. Don't forget that dot means and. Differently unless it is properly punctuated. It could mean the conjunction of P with the disjunction of Q with R. Parenthesis open. P dot bracket open Q or R bracket closed parenthesis closed. Or it might mean a disjunction whose first disjunction is the conjunction of P and Q. Parenthesis open, bracket open, P dot Q, bracket closed, or R, parenthesis closed. That the different ways of punctuating this statement do make a difference can be seen from the following case in which P is false while Q and R are both true. Brackets open, P dot Q, bracket closed, or R, and P dot bracket open Q or R bracket closed. In the first one, that is P dot Q or R, we have F, that's false, false, true, true, true. In P dot bracket close, P dot bracket open, Q or R bracket closed, we have false, false, true, true, true. From the above, the first statement is true and the second false. Here, the difference in punctuation makes all the difference between the truth of the first statement and the falsify of the second. For it is possible for the same set of ambiguous statements to have different values depending on how they are punctuated. In symbolic logic, we make use of 3 punctuation. That the different ways of punctuating this statement do not make a difference can be seen from the following case in which P is false while Q and R are both true. Bracket open, P dot Q, bracket close, V R. Don't forget that the dot sign represents and the V sign represents or. False, false, true, true, true. And P dot bracket open, Q V R bracket closed. That is P and bracket open, Q or R bracket closed. F, F, T, T, T. That is false, false, true, true, true. From the above, the first statement is true and the second false. Here, the difference in punctuation makes all the difference between the truth of this first statement and the falsify of the second, for it is possible for the same set of ambiguous statements to have different values depending on how they are punctuated. In symbolic logic, we make use of 3 punctuation marks. These are the brackets, comma, parentheses, and braces. Let us now symbolize the following compound statement by using letters A, B, C, and D to abbreviate. 1. Anambra wins its conference championship. 2. Benin wins its conference championship. 3. Calabar wins the Super Bowl. And 4. Delta wins the Super Bowl. 1. Either Anambra wins its conference championship and Benin wins its conference championship, or Calabar wins the Super Bowl. Bracket open, A and B, bracket closed, or C. 2. Anambra wins its conference championship and either Benin wins its conference championship or Delta does not win the Super Bowl. A and bracket open, B or not D, bracket closed. don't forget all the signs. Like I said earlier, the dot sign means and, the V sign means or, while the call sign means not. That's negation. 3. Anambra and Benin will not both win their conference championships, but Calabar and Delta will both not win the Super Bowl. Not bracket open, A and B, bracket closed, and bracket open, not C and not D, bracket closed. 4. Either Anambra or Benin will win its conference championships, but neither Calabar nor Delta will win the Super Bowl. Bracket open, A or B, bracket closed, and not bracket open, C or D, bracket closed. 5. Either Calabar or Delta will win the Super Bowl, but they will not both the Super Bowl. Bracket open, C or D, bracket closed, and not bracket open, C. 5. Either Calabar or Delta will win the Super Bowl, but they will not win both the Super Bowl. Bracket open, C or D, bracket closed, and not bracket open, C and D, bracket closed. 6. Both Anambra and Benin win their conference championships only if Calabar does not win the Super Bowl. Bracket open, A and B, bracket closed, then not C. Don't forget the then sign. That is this subset sign that faces the opposite side. 7. Anambra wins its conference championships if either Calabar wins the Super Bowl or Delta wins the Super Bowl. Bracket open, C or D, bracket closed, then A. 8. Anambra wins its conference championship and either Calabar or Delta wins the Super Bowl. A and bracket open, C or D, bracket closed. 9. If Anambra does not win its conference championship, then it is not the case that either Calabar or Delta wins the Super Bowl. Not A, then not bracket open, C or D, bracket closed. 10. Anambra wins its conference championship only if either Calabar or Delta does not win the Super Bowl. A, then not bracket open, C or D, bracket closed. Determining the truth value of propositions. Any compound statement constructed from simple statements using logical connectives has its truth value completely determined by the truth or falsehood of its component simple statements. as well as the truth condition of the connectives involved. In determining the truth value of compound statements, we always begin with their innermost components and work outwards. For example, let us assume that the statements represented by A and B in the following expressions are true, while those represented by X and Y are false. On the basis of this information and following our knowledge of the truth conditions of logical connectives, let us determine which of them are true and which of them are false. Number 1. Not A or not X. False, true, 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 false. Number 2. A or bracket open, X and Y bracket closed. True, true, false, false, false. Number 3. Bracket open, A or B bracket closed, and bracket open, X or Y bracket closed. True, 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 false, 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 false. Number 4. A and parenthesis open, X or bracket open, B and Y bracket closed, parenthesis closed. True, false, 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 true, false, false. Number 5. Not brace open, not parenthesis open, not bracket open, A and not X bracket closed, and not A parenthesis closed, and not X brace closed. False, true, false, true, 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 false, 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 true, 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 false. Number 6. Parenthesis open, bracket open as well, X and A bracket closed, Number 5. Not brace open, not parenthesis open, not bracket open, A and not X bracket closed, and not A parenthesis closed, and not X brace closed. False, true, false, true, 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 false, 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 true, 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 false. Number 6. Parenthesis opened, bracket open, X and A bracket closed, or not Y parenthesis closed, or not parenthesis open, bracket open as well, X and A bracket closed, or not Y parenthesis closed. False, false, true, 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 false, true, false, 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 true, 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 false. Number 7. Parentheses open. X or bracket open. A and Y bracket closed, parentheses closed, or not, parentheses open, bracket open, X or A bracket closed, or bracket open, X or Y bracket closed, parentheses closed. F, F, T, F, 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 T, 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 F, F, F. Number 8. Parentheses open, X and bracket open, not A, then Y, brackets closed, parentheses closed. If and only if, don't forget triple lines, means if and only if. Not bracket, not parentheses closed. Number 8. Number 8. Parentheses open, X and bracket open, not A, then Y, bracket closed, parentheses closed. If and only if, don't forget the 3 short lines are if and only if sign. If and only if, not parentheses open, bracket open, X or A, bracket closed, or bracket open, not X, then not Y, bracket closed, parentheses closed. False, 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 true, true, false, true, false, false, true, 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 false, true, true, false. Number 9. A, then, parentheses open, X, if and only if, bracket open, B, then, Y, bracket closed, parentheses closed. True, true, false, true, true, false, false. Number 10. Not, parentheses open, not, bracket open, not A, if and only if B, bracket closed, and not bracket open, X, if and only if, not Y, bracket closed, parentheses closed. False, true, false, true, false, true, 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 false, false, true, false. Symbolizing arguments. In symbolizing an argument, We write each of the premises if the argument has more than one premise on separate lines. The conclusion is usually preceded by 3 dots of a triangular shape, and it is written on the last line following the last premise. Study section summary. In this session, we focused on symbolizing statements and arguments in propositional logic and made use of special symbols and alphabetical letters. Among the alphabetical letters are capital letters A to Z, or propositional constants, representing actual propositions, and small letters P to W, or propositional variables, representing any proposition whatsoever. Among the symbols are those representing logical connectives as well as the various punctuation marks. In determining the value of a compound statement, we are guided by the truth value of its component simple statements as well as the truth condition of the logical connectives in the statement. Thank you for listening. This is the end of study section 9. Thanks for listening.